Hi everyone, in this video we're going to go ahead and talk about something called the Bohr model, which is a very useful tool for representing electrons. So let's go ahead and get started. Okay, so electrons are located in the area surrounding the nucleus, which is known as the electron cloud. However, science tells us that we cannot know the exact location of the electrons. We just know they're kind of in this general area. And we know that because of something called the Heisenberg uncertainty principle, meaning we can know either their speed or where they're at, but we can't know both of them. Since we have an idea about their speed, we don't know the exact location, but we have a rough idea. So one scientist who helped to develop this way of thinking about electrons is Niels Bohr, and he found that electrons are more likely to exist in certain parts of the electron cloud. And the areas where they're more likely to be found, he called orbitals. So Bohr also discovered that electrons can move between different orbitals by either absorbing or releasing a specific amount of energy, which is known as a quantum. So we look at this picture here. We have the nucleus in the middle, and we have the electron cloud surrounding it. The n equals 1 ring is the one that's orbital that's closest to the nucleus, and this takes the least amount of energy for electrons to be in this ring. And that's good because atoms like to be low in energy. As we move away from the nucleus, the amount of energy needed to be in n equals 2 or n equals 3 increases. So we want to fill up that smallest ring first and then move outward as we need to. So electrons can move from a lower energy orbital, one that's closer to the nucleus, to a higher energy orbital, one that's further away from the nucleus, by absorbing energy. They can also do the reverse, moving from a high energy orbital to a lower energy orbital by releasing energy. So this absorbing and releasing energy can be seen when we look at the color spectrums of the different elements. So in that bright colorful line up across the top, we see where hydrogen is absorbing. Those black lines are where it is absorbing specific wavelengths of energy. The emission is as it goes and gets rid of that energy as it's relaxing back down to the lower energy levels. So the key thing here is that each element has a unique amount of energy needed to move between the different energy levels. So because of this, each element has a different color spectrum or sequence of lines. So if I look at helium or neon or any of the other elements, I'm going to have a different pattern for my lines. This is the one, though, for hydrogen. And because each element has a unique pattern, we can actually use this to study different samples, including stars that are out in outer space, to figure out what makes up their composition. So in honor of the work that Bohr contributed to our understanding of the atom, we have named this model after him. Now, since his work, we have learned more about the atom, but his picture is still really helpful as it's a simple way to show us both the number of electrons and their location. So it's still important to use today. So thanks for watching. I hope this helps. If you have any questions, please let me know. Bye, everyone.